You probably ate seeds for breakfast today.
Yeah, or like stepped on a few during your morning commute.
Right, exactly.
Yeah.
Or if you keep a garden, you might occasionally press them into the dirt. But when was the last time you stopped to actually think about what a seed is? I mean, really think about it. You hold this dry, completely inert little pebble in the palm of your hand, you give it some water, and you just kind of expect it to magically become a 10-foot tomato plant.
We completely take that transformation for granted. We really do.
We do.
We treat them like inanimate objects,
Yeah.
like gravel.
Hmm.
But biologically speaking, that tiny little pebble is, well, it's arguably the most sophisticated survival mechanism on the planet. It's an evolutionary masterpiece.
And that is exactly our mission for this deep dive,
Hmm.
to unpack the sheer engineering marvel of this tiny biological stasis pod.
Yeah, it's going to be a fun one.
We are going to explore how seeds allowed plants to literally conquer the earth.
Hmm.
We'll get into the ingenious economic games they play to manipulate animals, the complex chemistry of how they wake up from centuries of sleep.
Which is just wild, by the way.
It really is. And finally, we'll dive into the billions of dollars and the fierce legal battles revolving around who actually owns them today. Okay, let's unpack this.
So to really appreciate the gravity of the seed, we have to travel back to a world before they existed.
Right, because plants haven't always had them.
Exactly. Around 468 million years ago, the first land plants evolved, and they reproduced using spores. And, ferns and mosses still do this today.
But spores have a massive limitation, don't they?
Oh, a crippling limitation. Spores are essentially single-celled, they're incredibly fragile, and crucially, they are highly dependent on water.
Like standing water.
Yeah, basically. The reproductive process of a spore-bearing plant actually requires a literal film of liquid water so the male gametes can physically swim to the female structure.
Oh, wow.
Yeah, so if a spore lands somewhere dry, or if there's a sudden drought, that entire genetic lineage is just finished. Because of this, early plants were basically chained to moist environments like swamps and coastlines. Vast stretches of the Earth's interior were just barren rock.
So plants needed a vehicle that could survive the dry land.
Right, they needed to decouple reproduction from liquid water, and that massive upgrade arrived during the late Devonian period. This is roughly 358 to 416 million years ago, with the very first seed-bearing plants, the gymnosperms.
The gymnosperms, which means, what, naked seeds?
Exactly. The word translates to naked seeds. Think of pine cones, right? The seeds develop right out in the open on the bracts, those woody scales of the cones. And it was a total revolution. Plants could finally move inland.
Because they weren't tied to the swamps anymore.
Right. And from there, evolution just kept iterating until we got the angiosperms, the flowering plants, which enclose the seed in an ovary that eventually ripens into a fruit.
Okay, let's look at the actual architecture of these enclosed seeds, because the internal engineering here is just mind-bending to me.
It's incredible.
Right. So every single angiosperm seed consists of 3 genetically distinct parts. First, there's the embryo, which is the actual baby plant formed from a fertilized zygote. Second, there's the seed coat, the testa, I think it's called, which is this heavy armor derived directly from the tissue of the mother plant. And third, there's the endosperm.
Yeah, and the endosperm is just a biological masterclass in resource management. It really is. It is created through a process called double fertilization.
Double fertilization. Okay, how does that work?
So when pollen reaches a flower's ovule, it delivers 2 distinct male gametes. One of those gametes fuses with the egg cell to create the embryo, but the other gamete, it actually bypasses the egg and fuses with a different central cell to form the endosperm.
And the endosperm is like the food supply. Really.
Right, it's a tissue with 3 sets of chromosomes, triploid tissue, that acts as the food supply.
Wait, I want to make sure I'm following the logic of this. Why 2 separate fertilizations? Because older plant lineages, like those gymnosperms we just talked about, they just build a massive nutrient supply inside the seed ahead of time, right?
They do, yeah. Gymnosperms invest massive amounts of metabolic energy into building a food supply for an embryo that doesn't even exist yet.
That seems risky.
It's a huge gamble.
Yeah.
If the pollen never arrives or the seed is never fertilized, the mother plant just wasted months of energy building a packed lunch for nobody.
Oh, I see.
Right, so angiosperms evolved to eliminate that gamble. They wait. They only trigger the synthesis of the endosperm at the exact microsecond the embryo is actually conceived. No fertilization, no wasted energy.
Oh, wow. Okay, so it's exactly like a sci-fi cryogenic pod. You've got the heavy armor on the outside, the seed coat. Inside, you have the sleeping occupant, the embryo, totally suspended in time.
Yes, perfectly suspended.
But the built-in nutrient paste, the endosperm, is only synthesized when the occupant actually climbs inside and locks the door. The plant doesn't waste resources building empty, fully stocked stasis pods.
That is an excellent way to conceptualize it. The endosperm is this highly concentrated package of oils, starches, and proteins. It is the literal fuel the astronaut uses to survive the long journey and eventually build its first root.
But, survival as a plant brings up a geographic problem. A stasis pod is completely useless if it just drops directly under the shadow of the parent tree.
Right, because there's no sunlight.
Exactly, there's no sunlight, and the parent tree is already monopolizing all the soil's water. The seed has to escape.
And since plants are rooted to the ground, they have to manipulate the environment to transport their offspring. I mean, the physical adaptations for this are stunning. Take an amokari, dispersal by wind.
Like dandelion hairs.
Yeah, dandelion hairs or the spinning samars of maple trees, those little helicopters. But the extremes of wind dispersal push the absolute limits of physics. Epiphytic orchids, for example, produce the smallest seeds in the world.
How small are we talking?
They measure just 85 micrometers long and weigh 0.81 micrograms.
Wait, really? Less than a single microgram?
Less than a single microgram. They are essentially biological dust. They don't even have an endosperm because the extra weight would ruin their aerodynamics. They simply catch the breeze and float for miles into the upper canopy of the rainforest.
That is wild.
And on the other extreme, you have hydrocary, which is water dispersal. Vines produce these highly buoyant sea beans that drop into rivers, float all the way out to the ocean, ride the currents for months, and then wash up on entirely different continents. Perfectly viable.
But the strategy that completely reframed how I look at nature is zoochory dispersal by animals. Specifically, myrmecochory, which is dispersal by ants. Because I always thought animals eating seeds was just a hazard the plant had to endure, like a total loss.
What's fascinating here is the sheer manipulation involved. Plants that use myrmecochory attach a highly specialized appendage to their seeds called an oleisum.
An oleisum?
Yeah. It's a fleshy, soft structure, absolutely packed with lipids and proteins, and it is chemically irresistible to foraging ants.
So the ant finds the seed, and it's carrying this incredibly calorie-dense snack. The ant grabs a whole package and drags it all the way back to its underground nest.
Right.
Once safely inside the colony, the ants devour the oleisum. But the seed coat itself is way too hard for their mandibles, so they can't eat the actual seed, so they haul the leftover seed to their underground waste pile.
Which is the ultimate botanical nursery. The seed is now protected from surface predators, it's shielded from drying out, and it's literally buried in a mound of ant compost, which is pure fertilizer.
I have to push back on how we normally talk about this, though. We always describe plants as passive. The wind blows them, the river takes them, an ant happens to pick them up. But looking at the oleisum, the plant isn't passive at all.
Not even a little bit.
Right. It's playing a complex economic game. It is manufacturing a highly specific currency to pay for a service. It's essentially paying for an Uber ride to a fertilizer dump, and the currency is just a lipid snack.
They are entirely driving the economy of that forest floor. And we see how vital that currency is when the economic system breaks down.
Oh, like when an invasive species comes in.
Exactly. In South Africa, the Argentine ant was introduced as an invasive species, and it aggressively outcompetes and displaces the native ants. But the Argentine ant doesn't play by the evolutionary rules of the oleisum. They ignore the seeds entirely.
So the Uber drivers all vanish.
Exactly. The Uber drivers vanish.
Yeah.
The seeds just drop directly under the parent plant and rot. As a result, the population of native seedlings like the mimese plant has just plummeted. The plants are producing the currency, but the new workforce completely refuses to accept it.
It's such an incredibly fragile web. But, escaping the parent plant is really only half the battle. Let's say our seed successfully pays for its ride. The native ant drops it in the nutrient-rich waste pile in late November. If it uses that fertilizer to sprout immediately, the winter freeze will just kill it. The seed has to know how to wait.
Right, and this brings us to the difference between quiescence and true dormancy.
Okay, what's the difference?
If a seed is just waiting because it's currently freezing or bone dry outside, that's enforced quiescence. The environment is holding it back. But true dormancy is an internal lockdown.
Like it physically won't sprout even if it could.
Exactly. You could put a dormant seed in a greenhouse with perfect soil, perfect moisture, ideal temperatures, and it will absolutely refuse to grow.
Because nature is incredibly deceptive. I mean, a randomly warm week in February could totally trick a quiescent seed into sprouting, and then bam, a frost in March wipes out the seedling. If a plant's entire genetic line falls for a false spring, that lineage goes extinct.
To prevent that, plants employ a strategy called bet hedging. A single parent plant will actually program its seeds with varying depths of dormancy,
Even from the same plant.
even from the exact same harvest. Some seeds are chemically locked down to wait 1 year, others 2 years, some maybe 5 years. It spreads the generational risk across time, so no single catastrophic weather event can wipe out all the offspring.
The mechanisms they use to lock themselves down are intense, too. There's physical dormancy, where the heavy armor of the seed coat is literally impermeable. Water cannot get in. The coat contains a microscopic water gap that is structurally designed to only rupture under very specific environmental stress.
But waiting carries a huge biological cost. Even in a state of deep stasis, the molecular machinery inside the embryo is slowly degrading.
Right, because nothing lasts forever.
Exactly. Over years in the soil, the seed's DNA accumulates severe damage. Single-strand breaks, double-strand breaks. It's just the inevitable cellular decay of aging.
Which leads to one of the most remarkable things a seed does. When it finally gets the environmental signal to wake up, it doesn't just start growing leaves. It has to fix the decay first.
It's amazing. Before a single cell divides, the seed runs a massive system diagnostic. It deploys specialized enzymes, specifically PIRP, poly-ADP ribose polymerases.
Okay.
Using the metabolic energy stored in the endosperm, these enzymes scour the embryo's entire genome. When they find a break in the DNA helix, they synthesize long chains of molecules to flag the damage and literally stitch the double helix back together.
Hold on, it's repairing its own genetic code in the dark before it even has a root system.
Yes, and if that repair mechanism is overwhelmed by too much damage, the seed intentionally aborts germination and just dies. It's a flawless quality control system.
That's Sleeping Beauty. So what does this all mean? We have this heavily armored pod carrying a sleeping embryo that can repair its own DNA, locked away until the exact right moment. How does it know the moment has arrived? Like, what actually breaks the curse?
Well, it requires extreme environmental triggers. Some seeds require scarification.
Meaning they have to be scratched up.
Yeah, or they have to be swallowed by a rodent and pass through a highly acidic digestive tract. The stomach acid dissolves just enough of the seed coat to allow water to penetrate that water gap. In agriculture, humans actually mimic this by soaking seeds in acid or physically sanding them down.
Other seeds need stratification, right? A prolonged period of moist, freezing temperatures.
Right. They have to physically feel a long winter so their internal chemistry knows that spring has truly arrived. And then there's my personal favorite, pyrogenic germination.
Fire.
Fire. For certain forest species, the intense heat of a wildfire is literally required to physically crack the seed coat. For others, the dormancy is chemical, and the lock is only picked by the presence of specific compounds found in smoke.
Liquid smoke.
Yeah. The evolutionary logic is brilliant, really. The smoke signals to the seed that the towering canopy trees have burned down. There is finally sunlight hitting the forest floor, so now is the time to strike.
The patience involved is just legendary. And there is a documented record holder for this waiting game. A Judean date palm seed was recovered during archaeological excavations at Herod the Great's palace in Israel at the fortress of Masada.
Oh, I know this one.
Yeah, carbon dating placed this single seed at roughly 2,000 years old. It sat in the dirt through the fall of the Roman Empire, the Middle Ages, the Industrial Revolution. And in 2005, scientists provided the right conditions, and it successfully germinated.
It perfectly encapsulates the resilience of that biological stasis pod. But this raises an important question.
Okay, what's that?
If we connect this to the bigger picture, we've explored how seeds conquer the natural world, but we really need to look at how they intersect with us. Because human civilization is entirely built on consuming these stasis pods.
We are an endosperm-powered species.
We really are.
The vast majority of global human calories come from seed cereals like wheat, rice, and corn, and legumes like beans and lentils. Our entire agricultural infrastructure is essentially just a machine designed to mass-produce that triploid nutrient paste.
But plants do not surrender their reproductive future willingly. They engage in brutal chemical warfare to protect their embryos from herbivores and humans alike.
They fight dirty. The sources of our calories are often naturally laced with toxins, like Castor beans contain ricin, one of the most potent toxins known to science.
It's terrifying.
A lethal dose for a human is horrifyingly small, just 2 to 8 crushed seeds.
And it extends to the fruits in your own kitchen. The seeds of apples, cherries, peaches, and plums, they all contain amygdalin. When chewed and digested, amygdalin degrades directly into hydrogen cyanide.
Wow.
Even the common kidney bean contains high levels of proteins called lectins. If you eat them raw, they cause severe gastric distress and vomiting. Early humans had to master fire to chemically degrade those lectins through boiling, just to safely access the calories inside.
Here's where it gets really interesting for me. We've tracked this journey from dust-sized particles floating on the wind, trying to poison us to protect themselves, to where we are today. The seed is now the foundation of a highly lucrative, heavily locked down intellectual property market.
Yeah, the modern seed is as much an economic and legal entity as it is a biological one. In commercial agriculture, seed vigor is everything. You need maximum viability, rapid germination, and uniform seedling strength.
Right.
To achieve this, agricultural corporations have poured immense capital into genetically optimizing these traits.
And the scale of that optimization is just staggering. In the United States alone, farmers spent $22 billion on seeds in 2018. And that market is remarkably consolidated.
Very consolidated.
Just two massive entities, Dow DuPont and Monsanto, account for 72% of all corn and soybean seed sales in the U.S. A single bag of genetically modified corn seed can average around $270.
Which introduces a deeply complex legal tension over ownership. For the entirety of human agricultural history, the core practice was seed saving.
You just keep some for next year.
Exactly. A farmer harvests their crop, saves the most robust seeds from that yield, and plants them the following spring for free. But modern seed varieties are heavily patented. The corporations that develop them require farmers to sign agreements prohibiting the saving of seeds, compelling them to purchase new stock every single year to recoup the massive research and development costs.
And this tension isn't just theoretical, it's playing out in Supreme Courts right now. Our sources note a major flashpoint that occurred in Kenya in 2025. The High Court of Kenya made a landmark ruling declaring that laws restricting farmers from using, sharing, or selling their own saved seeds were unconstitutional.
It is a profound shift in agricultural law. Development charities like the UK-based KFUD have really highlighted this ruling as a crucial precedent. Their argument is that restrictive seed laws centralize control of the global food supply into the hands of a few giant corporations. KFUD has actually publicly criticized major financial institutions, including the World Bank, arguing that while the bank didn't directly author the Kenya law, it promotes a broader economic framework, or a logic of profit, that prioritizes corporate intellectual property rights over the traditional practices of small-scale farmers.
And we see similar advocacy from groups like Caritas Zambia, raising identical concerns about the World Bank's influence on seed legislation in their country. So you really have this intense global tug of war.
You do.
On one hand, you have billions of dollars necessary to research and develop high-yield, drought-resistant seeds that can feed a rapidly growing global population. And obviously, those companies need to protect their inventions. But on the other hand, you have advocacy groups fighting for seed sovereignty, arguing that the right to save and replant is a fundamental human right.
The seed has totally transitioned from a botanical marvel into a legal battleground.
Yeah.
Because fundamentally, whoever controls the seed controls the food supply.
It's incredible to zoom out and look at the entire journey. We started by looking at a piece of dust. From the microscopic epiphytic orchid seed floating into the canopy, all the way to the 25-kilogram coco de mer seed drifting across the ocean.
Oh yeah, those are massive.
Right. These biological vaults masterminded a planetary expansion. They invented currencies to bribe insects. They evolved to survive wildfires and stomach acid. They can sit dormant in the dirt for 2 millennia waiting for the right moment to repair their own DNA. And eventually, they became the calories that built human civilization and the basis of a $22 billion global industry.
They are the ultimate survivors. And yet there is one final detail about their biology that completely reframes everything we've discussed today.
The seed microbiome, this completely blew my mind.
When you hold a seed in your hand, you naturally assume you are looking at a single organism, a solitary baby plant wrapped in a pod. But you aren't.
You are looking at an ark.
Exactly. Seeds harbor a highly diverse, complex community of microorganisms, specific strains of bacteria and fungi. And these microbes are not random contaminants from the dirt. They are actively and intentionally transmitted from the parent plant, through the vascular tissue, directly into the seed.
It's a living inheritance. The mother plant isn't just packing the stasis pod with an embryo and a nutrient paste. She is packing it with an entire microscopic ecosystem designed to establish itself on the seedling's roots and protect it against disease the exact moment it wakes up.
It changes the entire paradigm. It's not a solitary plant waiting in the dark. It's a symbiotic community, a highly curated microbiome, just waiting to be unleashed into the earth.
So the next time you sit down to breakfast or you step on a stray acorn on the sidewalk, remember what you're actually looking at. It's an ancient, heavily armored, genetically self-repairing stasis pod carrying a sleeping astronaut and a microscopic alien ecosystem, just waiting for the perfect moment to conquer the world. Keep exploring, keep questioning, and we'll see you on the next deep dive.
If you asked the average news pundit today what the word Sharia means, they would almost certainly picture this really rigid courtroom.
Oh yeah, absolutely. Or like a strict judge pounding a gavel.
Right. But looking at the massive stack of notes you've brought us for this deep dive, the concept, well, it doesn't start with a judge.
No, it really doesn't.
And it doesn't even start in the city. It begins with a literal, like, life or death survival path to a watering hole in the Arabian desert.
Exactly. The linguistic root of the letters are historically referred to watering animals at a permanent water hole, or the physical pathway you actually had to follow to get there.
Wow.
Because in a harsh, arid desert environment, wandering off that path didn't just mean getting lost. I mean, it meant you didn't survive.
You die, yeah.
Right. So over time, that literal pathway to water was adopted as a metaphor for a divinely ordained way of life.
Which makes total sense, right? Like a path to water is literally a path to life. So the metaphor naturally becomes the path a believer has to follow to reach spiritual sustenance.
Precisely. It's the path that keeps you spiritually alive.
Now, before we really get into the weeds here, I want to clarify something for you, the listener. Because you've handed us a stack of sources today on what is arguably one of the most politically charged topics on Earth.
Oh, without a doubt. It touches on theology, human rights, democracy, everything.
Exactly. So I want to explicitly state our mission here today. Our only job in this deep dive is to act as your high-level scouts. We aren't here to referee theology or debate democracy or take any political sides whatsoever.
Right. We're strictly impartial today.
Totally impartial. We are simply mapping out exactly what your sources say about how the system actually works, where it came from, and, how it collides with the modern world. We're just conveying the ideas as they exist in the text.
And honestly, the absolute best place to start that mapping is with a distinction in your notes that, it clears up about 90% of the public confusion right out of the gate.
Oh, really? What's the distinction?
It's the fundamental difference between two concepts, Sharia and fiqh.
Okay, Sharia and fiqh.
Right. So in classical Islamic theology, Sharia is the divine ideal. It is the perfect, flawless, immutable law as set down by God.
But the notes stress that Sharia itself is mostly intangible, right? It's like this ultimate ideal.
Exactly.
The actual laws that got applied in historical societies, those fall under fiqh, which translates to Islamic jurisprudence.
Yeah. Yes. Fiqh is the human attempt to understand it.
So is this kind of like the concept of true north on a compass versus the actual map drawn by a human cartographer? Like, true north Sharia is fixed and perfect, but fiqh is the map drawn by a flawed human trying to figure out how to get there.
That is a brilliant analogy.
Yeah.
Yes. And taking that compass analogy further, because humans are the ones drawing the map, you inevitably get different borders and different routes.
Depending on who's holding the pen, right?
Exactly. And when they're drawing it, the human attempt to interpret the divine is inherently fallible.
Which means mistakes happen.
Right. That is why Islamic history isn't just one giant monolithic legal code. I mean, it is filled with different competing schools of law. These human cartographers developed entirely different methodologies for deriving everyday rulings from the sacred texts.
And your sources point out that this framework isn't totally unique to Islam, which I found fascinating.
Oh yeah, the parallels are striking.
You see a very strong structural parallel in Jewish law, halakha, which actually also translates to the path to follow.
Yes, it's the exact same metaphorical concept.
Both traditions rely heavily on a revealed textual law that then requires this really intense, ongoing interpretation by a class of highly trained scholars.
Which naturally leads us to the methodology those scholars actually use. I mean, if you are a medieval jurist trying to draw this map of fiqh, you don't just guess.
Right, you need tools, you need a system.
Exactly. Traditional Sunni jurisprudence recognizes a strict hierarchy of 4 primary sources to build the law. First is the Quran, obviously. Second is the Sunnah, which are the recorded traditions and sayings of Muhammad.
Okay, so those first two establish the baseline scriptural texts.
Right.
But looking at your notes on how they built this law, the third and fourth sources are what really caught my eye. Because they basically solve the time travel problem.
Non-travel problem.
Yeah. I mean, the sacred texts are finite, right? They were written at a specific time, but time keeps moving. New stuff gets invented. So their third tool to handle that is ijma, right? The consensus of the scholarly community.
Yes, ijma. And the underlying theological justification there is really interesting. There's a recorded tradition stating that the Islamic community would never unanimously agree on an error.
Wow. So if all the experts agree, it becomes law.
Essentially, yes. If the top tier of legal minds across the empire reach a consensus on an issue, that consensus gains the force of law. But the real engine of daily legal adaptation, the thing that keeps the law moving forward, is the fourth source, qiyas.
Qiyas, which means analogical reasoning, right?
Exactly, analogical reasoning.
The sources gave a brilliant example of qiyas in action. Let's see if I have this right. So the text explicitly forbids the drinking of wine.
Right, that's firmly in the text.
But then fast forward a few centuries, and entirely new intoxicating drugs appear on the scene. A strict literalist reading would say, well, you know, the text only mentions wine made from grapes, so this new chemical powder is perfectly fine.
Which obviously defeats the whole moral purpose of the law. So, using qiyas, a jurist looks beneath the literal text to identify what they call the ilah.
The ilah.
Yeah, it translates to the effective cause of the ruling. The jurist asks, okay, why is wine forbidden?
Because it intoxicates you.
Exactly. The cause is intoxication. Therefore, they analogize the new substance to the old one. If the new drug intoxicates, the prohibition against wine legally extends to it.
That is so elegant. It's a highly rational mechanism for the law to adapt to new technologies and new substances without requiring a new prophet or, brand new scripture.
It really is. It makes the system incredibly resilient.
Wait, but here is where your stack of notes introduces a massive historical contradiction. Because you just laid out this immaculate orthodox theory where the law flows perfectly down from divine texts through consensus and careful analogy.
Right, that's the traditional view.
But your notes from modern historians, specifically this revisionist school led by scholars like Joseph Schott, they paint a completely different picture of how this actually happened on the ground.
Oh, completely. The revisionist view fundamentally challenges that neat, top-down traditional narrative.
How so?
Well, Schacht and others point out that the early Arab empires expanded at a blinding speed in the 7th and 8th centuries. I mean, they conquered highly populated, very complex urban societies.
Like the Persian and Byzantine territories.
Exactly. And those territories already had their own deeply entrenched administrative needs and laws. The revisionist argument is that early Islamic law wasn't drawn up in a vacuum from scripture alone.
But what did they do?
They aggressively absorbed the existing pre-Islamic customs and the common laws of the conquered peoples, and then only later on gave them an Islamic theological justification.
The archaeological examples in your notes regarding this are wild. They point to pre-Islamic Sephardic inscriptions that detail pilgrimage rituals that look strikingly similar to later Islamic practices.
Yes.
Or even crazier, look at the pre-Islamic tribal concept of qisas. In tribal Arab society, if someone was murdered, the victim's tribe would demand the execution of a social equal from the murderer's tribe.
Right. It was pure intertribal blood feuding. An eye for an eye, but based on social rank.
Yet, as the empire formed, that raw, brutal tribal custom was absorbed and domesticated into the legal code.
It was. It was transformed into a system of civil dispute resolution between individual believers.
Which is such a massive shift.
It really is. Instead of the state prosecuting a murder like we're used to, it was treated as a private dispute where the victim's family could demand equal retaliation. Or, and this is crucial, they could accept diya.
Diya is the financial compensation, right? Blood money.
Exactly. They could accept blood money instead of an execution.
So how does a listener reconcile a divine, perfect law with historical evidence that they seemingly just copied and pasted tribal blood money rules and Byzantine administrative laws?
That's the big question. And you reconcile it by understanding that the human cartographers we discussed earlier, the jurists, they were incredibly pragmatic.
Meaning what exactly?
Meaning, they believed the divine intention was to establish a just and functional society. If a local Byzantine market regulation or a tribal dispute mechanism served the public good, and it didn't directly contradict the core monotheistic theology.
And they just integrated it.
Exactly. They Islamicized the local customs. The law was a living, breathing synthesis of divine text and social utility from day one.
Which entirely changes how you view their system of categorizing human behavior, because they didn't just regulate murders and big market disputes. Your notes on the Occam the Five Decisions show a framework that covers microscopic daily habits.
Oh, it covers everything. Every single human action is dropped into one of 5 buckets: mandatory, recommended, neutral, reprehensible, and forbidden.
See, bringing categories like neutral or recommended into a legal code radically changes the nature of a courtroom. It transforms the law from just a strictly punitive list of thou shalt nots into, like, a comprehensive ethical map.
That's a great way to put it, an ethical map. For example, brushing your teeth in a specific manner might be recommended. Drinking a glass of water is neutral.
And wasting water while washing your hands might be reprehensible, meaning it's sinful, right?
Right.
But a judge is going to throw you in jail for it.
Exactly. The worldly courts only really deal with the extremes, the mandatory and the forbidden. The rest is about personal spiritual ethics.
But if the law is that granular, if it covers exactly how you wash your hands, that creates a massive problem for you, the listener, trying to understand how this survives.
What do you mean?
Well, how does a medieval framework governing daily habits survive the invention of the printing press or the modern global banking system? If the rules are that stubbornly specific, the system should have just snapped centuries ago.
It would have if it were entirely rigid. But the system survived because of a built-in tension between 2 legal mechanisms: ijtihad and taqlid.
Okay, break those down for us.
Sure. So ijtihad is the intense, independent mental effort by a highly qualified legal scholar to derive a ruling for a totally unprecedented situation.
So that's the innovation side.
Right, and it requires a staggering mastery of Arabic, theology, and precedent. You can't just be a guy on the street.
And taqlid is essentially the opposite, right?
Yes, taqlid is conforming to precedent, relying on the established decisions of previous masters. Because, you don't need to reinvent the wheel every time someone asks a basic question about how to pray.
So there's this balance between innovating and relying on the old masters.
Exactly. And the historical debate has always been over whether the gates of ijtihad were ever formally closed by medieval scholars.
Why would they close them?
To prevent unqualified people from just making up laws, but many argue the duty to apply independent reasoning remained open. And to guide that independent reasoning, jurists developed a concept called maqasid.
Maqasid, which translates to the overarching aims or objectives of Sharia.
Correct. And your sources highlight the 11th century philosopher Al-Ghazali here. His framework is absolutely fascinating.
Yeah, I love this part, because he argued the divine law wasn't just this random list of arbitrary tests for humanity. The ultimate goal was human welfare.
Exactly. Al-Ghazali identified 5 core essentials that the law is fundamentally designed to protect: religion, life, intellect, offspring, and property.
So his logic dictates that any legal ruling that protects those 5 essentials serves the public interest, and anything that harms them violates the spirit of Sharia.
Precisely. It's a very utilitarian way of looking at divine law.
And think about what that means for the modern world. Modern scholars are picking up this exact 11th century Maqasid framework and using it to argue for incredibly contemporary concepts.
Oh, they use it constantly today.
Right. They argue that if the ultimate divine goal of Sharia is to protect the human intellect and property, then democratic elections, freedom of speech, and women's property rights, they aren't Western imports at all.
No, they frame them as the purest modern expressions of Sharia.
Exactly. They use this medieval philosophy to argue for a highly fluid, progressive application of the law today.
It is a brilliant intellectual maneuver, honestly. It bridges classical theology with modern governance. However,
There's a
big however. The theoretical elegance of protecting human welfare heavily collides with the area of Sharia that grabs all the modern headlines: the criminal justice system.
Oh, yeah. We absolutely have to dig into the criminal law section of your notes, because the reality of how these courts historically function is deeply counterintuitive.
It really is. The sources divide Islamic criminal law into 3 distinct categories.
Right. And the first one is had.
Yes, have. These are crimes considered to be committed directly against God's limits, and they carry specific, severe punishments detailed directly in the scriptural texts.
This is where you find the punishments that shock the modern conscience,
Yeah.
right? Like amputation for theft or stoning for certain sexual offenses.
Exactly, that's headed. The second category, as we discussed earlier, is qisas and diya. That deals with bodily harm and murder, treating it as a civil dispute between the families involved.
Right, the blood money stuff. And then the third category is tazir, which covers offenses that just have no specified scriptural punishment.
Right. With tazir, the judge or the state has almost complete discretion to determine the penalty based on the severity of the crime.
And the notes indicate the vast majority of historical criminal cases were handled under this discretionary tazir category, not had.
Yes. And the reason the vast majority fell under tazir brings us to one of the most critical sociological mechanisms in all of Islamic jurisprudence.
Yes. The evidentiary catch-22 regarding those extreme had punishments. This blew my mind.
It's fascinating, isn't it?
It really is.
Yeah.
Because you read the headlines today and you just assume these brutal punishments were being handed out constantly. But your notes detail how the classical jurists engineered a system deliberately designed to make executing these punishments nearly impossible.
Completely impossible in many cases. Let's take the crime of adultery. The foundation for the law goes back to a famous incident known as the necklace story involving Aisha, who was the prophet's wife.
Okay, what happened?
After she was falsely accused of infidelity, a strict evidentiary rule was established to prevent slander and protect reputations. To secure a conviction for adultery under had, the court required 4 adult male eyewitnesses.
4 eyewitnesses.
Not just circumstantial evidence, not just seeing 2 people enter a room together or seeing them holding hands. 4 eyewitnesses who saw the actual physical act of penetration occur.
Which, I mean, you might be wondering, how could anyone ever meet that burden of proof?
You can't, not unless they are doing it in the middle of the town square.
Right. And that is the entire point.
Yeah.
Because here's the second half of the catch-22. If you bring an accusation of adultery to the court, but you can only produce, say, 3 eyewitnesses instead of 4.
The case is thrown out.
And you, the accuser, receive 80 lashes for the crime of slander.
Wow. Think about the chilling effect of that.
It's massive. The classical jurists deliberately constructed an evidentiary threshold that was practically insurmountable.
They did, and the aha moment here is understanding their motivation. The jurists weren't just being lenient for the sake of it. They were actively managing state power.
How so?
Well, they believed the primary goal of the had punishments was deterrence through the sheer terror of the theoretical threat. They wanted to maintain public morality by keeping this scary punishment on the books.
But they also knew that actually executing people or chopping off hands causes massive social unrest. It fractures communities.
Exactly. So they engineered a legal paradox. They kept the terrifying divine threat on the books to uphold the theological ideal, but they rigged the procedural rules to ensure the state almost never had the legal authority to actually execute the punishment for a moral failing.
It's wild. The system prioritized preserving life and social harmony over retributive violence.
It is a masterful piece of sociological engineering, and this is but that intricate balance, where independent jurists acted as a buffer between the raw text and the citizens, that was completely upended by the arrival of the modern era.
Which leads us to the final major section of your notes. How does a system run by independent scholars drawing these fluid maps survive the invention of the modern nation-state? And frankly, the onslaught of European colonialism?
The short answer is it didn't, not in its classical form.
It broke down.
Yeah. The 19th and 20th centuries forced a massive paradigm shift. As Muslim-majority countries centralized power into modern nation-states, they couldn't rely on hundreds of independent scholars issuing varied, conflicting opinions.
Right. A modern state needs uniform laws.
Exactly. So the state took over the law. They began codifying their laws into rigid, formal statutes, effectively freezing those fluid maps into state-mandated borders.
And your sources show this resulted in a hybrid system in a lot of these countries. The governments imported European civil codes, like French or British models, to handle commercial and criminal law because, well, they needed to interface with the global economy.
Right. You can't trade globally if your commercial laws are completely incompatible with the rest of the world.
So they restricted Sharia primarily to family law, marriage, divorce, inheritance.
Yes. The independent scholar was replaced by a government committee. But human nature dictates that everyday believers still crave moral guidance for their daily lives, stuff outside the scope of a government family court.
And that craving sparked the fascinating modern evolution of the fatwa.
It really did.
Because historically, your notes explain that a fatwa was an incredibly dense, technical legal brief. An independent scholar would issue a fatwa to a judge to help resolve an unprecedented legal question in a specific court case.
It was essentially the equivalent of a Supreme Court amicus brief. Very high-level stuff.
But today, the fatwa has been completely democratized. And as a result, it is deeply fragmented. Because the state took over the formal courts, independent religious scholars just migrated to new platforms.
Oh, yeah. We are talking about internet forums, satellite TV call-in shows, and now social media.
It's crazy. You have everyday people texting questions to a scholar in another country, seeking a fatwa on the most modern dilemmas imaginable.
Give me some examples from the notes.
Oh, they are fascinating. There are fatwas addressing the permissibility of cryptocurrency, the ethics of medical sex change operations, and my absolute favorite, whether a Muslim astronaut on the International Space Station still needs to pray facing Mecca when the Earth is literally spinning below them.
That is incredible, and it represents the ultimate decentralization of religious authority. Anyone with a smartphone can now seek out a scholar whose specific map, going back to our analogy, aligns with their personal views.
But this decentralization also fuels the intense, often violent ideological clashes we see globally today.
It does. It really does.
Looking at the contemporary flashpoints in your sources, we see a massive active collision between ancient texts and modern global standards. And again, acting as your neutral scouts here, we aren't judging the validity of either side, just mapping the terrain of the friction.
Right. So on one flank of this friction, you have fundamentalist and revivalist movements. They view the historical codification and European influence as a complete corruption.
They want to go back.
Exactly. They demand a return to what they view as a pure implementation of Sharia, and they frequently push to reinstate those severe had punishments as a direct rejection of Western modernity.
But then on the opposing flank, you have the modernist scholars we discussed earlier, the ones using the Makasi, the welfare objectives, to argue that the classical text must be reinterpreted to align perfectly with the UN Declaration of Human Rights.
And the friction points between these two sides are highly specific in the sources.
Oh, totally. Your notes highlight the European Court of Human Rights explicitly ruling that a specific political implementation of Sharia was completely incompatible with democratic pluralism.
Yeah, that was a landmark ruling.
There are ongoing fierce debates within these countries regarding apostasy laws, like whether the state can punish someone for changing their religion. The tension is incredibly high regarding women's rights, particularly in inheritance distribution and domestic violence laws, where traditional literalist readings clash violently with modern egalitarian views.
And similarly, classical jurisprudence faces massive pushback from contemporary frameworks regarding LGBTQ rights.
You are watching a real-time battle over who gets to draw the map for the 21st century. But, and this is where the deep dive takes a really surprising turn, the impact of these legal frameworks isn't restricted to just social rights or criminal court.
No, it's not. There is a profound, often overlooked economic consequence hidden in the structure of classical Sharia.
I am so glad we have time for this, because the economic theory from Timur Kuan in your notes provides a massive aha moment regarding global history.
I love this theory. It really changes how you view history.
It does, because we often wonder why the Middle East, which was historically the absolute center of global trade and wealth, fell behind Europe economically in the early modern period.
Right. And Quran theorizes it comes down to a single missing legal concept in classical Sharia: the corporation.
The corporation, which sounds so dry, but the implications are staggering.
They are, because in classical Islamic jurisprudence, the law only recognized natural, living human beings. It had no concept of a fictitious legal person, what we call a corporation, which can own assets, take on debt, and exist entirely independently of its human founders.
Okay, so if I start a business, it's just my business. It doesn't exist outside of me.
Exactly. And you have to combine that missing concept with the incredibly strict Quranic inheritance laws. The text mandates that wealth must be distributed among a very wide network of extended family members upon a person's death.
So you couldn't just leave your entire business to your eldest son to keep it intact.
No, you legally had to fracture it. Functionally, this meant that if a highly successful merchant built a massive, booming shipping enterprise, the moment he died, that enterprise had to be liquidated and fractured into dozens of pieces to satisfy all those inheritance laws.
The business literally died with the human,
Yes.
which means you couldn't accumulate capital over multiple generations to build a massive multi-century trading company like, say, the Dutch East India Company.
Precisely. Because the legal map lacked the concept of a corporation, it functionally prevented the accumulation of massive generational wealth, which in turn severely delayed the onset of industrialization and modern accounting in the region.
It is staggering to realize how the absence of one abstract legal concept can entirely alter the economic trajectory of half the globe.
It perfectly illustrates how deeply the mechanisms of jurisprudence weave into the very fabric of a civilization's survival and growth.
It really does.
Yeah.
Which brings us to a final thought for you to ponder based on this massive stack of sources today.
We've covered a lot of ground.
We really have. We've traced this concept from a literal survival path in the desert. We've watched human scholars draw wildly complex maps over centuries, unpacked a criminal justice system that was sociologically engineered against its own punishments,
And examined a system currently fracturing across the internet and colliding with modern economics and human rights.
Right. And the overarching theme of your sources is that early Islamic law was never a static monolith. It was fiercely dynamic.
It absorbed the Sephidic pilgrimage rituals, it integrated Byzantine market rules, and it domesticated pre-Islamic tribal blood money customs.
It survived by synthesizing the divine ideal with the practical realities of the societies it encountered. So, if Sharia is fundamentally this living tradition that historically evolved by absorbing the customs of the world around it, we leave you with this question.
What does it absorb next?
Exactly. When this ancient framework fully collides with the hyper-connected, digitized, and culturally blended realities of the 22nd century, what new administrative customs will it integrate? What will the cartographers of tomorrow's map decide is the true path to water?
It is an open question, and history suggests the answer will be vastly more pragmatic than the headlines ever portray.
Thank you for sharing your notes and joining us on this deep dive. Keep questioning the buzzwords, look past the headlines, and we'll see you on the next one.
You know, usually when we think about our DNA, we picture this incredibly rigid, finalized blueprint, like a movie script that has already been printed, bound, and handed out to all the actors.
Right. Yeah. It's a comforting thought, honestly. You get what you get. The script is totally set, and, well, that's the end of the story.
Exactly. Your eye color, your height, your biological destiny, it's all just locked in from day one. But then, you look at your own body and suddenly that whole analogy just falls apart.
Oh, completely falls apart.
Because think about it, your DNA is largely the exact same in every single cell of your body. So if the script is identical, why does a heart cell look and act completely differently than a brain cell?
Yeah, how does the heart cell know to beat right?
Right. While the brain cell knows how to, fire an electrical signal.
It really is a biological paradox when you first start to unpack it. And honestly, it's the perfect entry point into the concept we're exploring today,
Yeah.
which just completely upends that rigid view of biology.
So welcome to today's deep dive. We are exploring the invisible layer of biology called epigenetics. Based on the comprehensive Wikipedia overview we're unpacking today, we're going to figure out how your body regulates, reads, and alters the expression of your genetic code.
Without actually changing a single letter of the underlying DNA sequence.
Exactly. We're going to see how your daily life alters your biology and ask the massive question: can you pass your life experiences down to your descendants?
The word itself actually gives away the secret. The Greek prefix epi means on top of or in addition to. So epigenetics is literally the science of what is happening on top of your genetics.
Okay, let's bring this back to that movie script analogy for a second. If your DNA sequence is the typed dialogue of the script, epigenetics is like the director's notes.
Right.
It's the highlight or the crossed out lines, the margin doodles that dictate how the script is actually performed by the actors. The underlying words haven't changed at all, but the final performance is completely different.
I take that even further, actually. It's not just notes on the page. It's whether the actor is even allowed to open the script to a certain scene in the first place.
Oh, wow. Okay.
Yeah. So to understand how the environment changes our bodies, we really have to look under the hood at the physical mechanisms our cells use to actually highlight or cross out parts of that DNA script.
Right. So we're talking about chromatin remodeling. But before we get into the heavy weeds there, I'm picturing a microscopic construction zone. How does a cell actually restrict access to the script?
Well, think about the physical reality of DNA. It is incredibly long. If you took the DNA in just one of your microscopic cells and stretched it all the way out, it would be about 2 meters long.
Wait, 2 meters in one tiny cell?
Yep. 2 meters. So to even fit inside the cell nucleus has to be packed incredibly tight. It wraps around these spool-like proteins, which are called histones.
Okay, so if it's spooled up super tight, the cell's machinery just can't get in there to read the genes. The script is basically glued shut.
That is the default state, yeah. And this brings us to the first major epigenetic mechanism, which is histone modification.
Okay.
So when the cell needs to turn a gene on, say, a gene that tells a stomach cell to produce acid, it attaches a chemical tag to the tail of that histone spool. A really common one is an acetyl group.
So this acetylation process, does it physically change the spool itself?
It does. Adding that tag literally neutralizes the positive electrical charge on the histone protein. And because DNA has a negative charge, neutralizing the spool loosens its magnetic-like grip on the DNA.
Oh, that makes sense.
Right. So the DNA unwinds just a little bit, the gene is exposed, and the cellular machinery can finally get in there and read it.
Okay, so loosening the spool is the highlighter. It tells the cell, hey, read this part. So what's the black marker? How do we cross a line out so a skin cell doesn't accidentally start producing stomach acid?
That would be the second main mechanism, which is DNA methylation. Instead of modifying the spool, the cell adds a tiny chemical tag, a methyl group, directly to the DNA molecule itself.
Directly to the DNA.
Directly to it, especially at these places called CPG sites. Think of it as a molecular do not read sticker. When these stickers pile up at the starting block of a gene, they physically block the machinery trying to read it. The gene is silenced.
Got it. So a liver cell is a liver cell because it has do not read stickers plastered all over the brain cell instructions, but it has unwound and highlighted all the liver cell instructions.
It's exactly the core of cellular differentiation, yes.
Which brings up this historical concept we came across from the 1940s, the epigenetic landscape. It was proposed by this British embryologist, C.H. Waddington. I found this fascinating, but a little tricky to visualize.
Yeah, Waddington's epigenetic landscape is a super classic visualization in biology.
Right, so he described embryonic cells as marbles resting at the very top of a hill.
Imagine a hill with all these various valleys and branching pathways leading down.
Okay, yeah. So as the embryo develops, the marble starts rolling down the hill, and it falls into a specific valley. As it keeps rolling, the valley gets deeper, which restricts the marble's path more and more.
Until eventually, it reaches the bottom and is trapped in that one specific valley. It has irreversibly become a liver cell.
But what I don't quite get is, what physically stops the marble from just rolling back up the hill? What keeps it trapped?
The walls of those valleys are physically built out of the epigenetic tags we just talked about. The methyl stickers and the tightened histones are the actual barriers preventing that marble from rolling up a ridge and suddenly turning into a heart cell.
So they lock the cell into its fate.
Exactly.
But if these tags are just physical stickers or tightened spools, how permanent are they really? Because our cells are constantly dividing and replacing themselves, right?
Right, all the time.
So if I cut my arm, my skin cells have to divide to heal it. When a skin cell splits in two, do the stickers just fall off? Does the new cell have to figure out its identity all over again?
That is a massive biological vulnerability you've just hit on. If they fell off, we'd literally dissolve into a chaotic mass of confused cells. So no, these epigenetic states are heritable during cell division.
Wait, heritable? Like the cell passes it down?
Yes. Your body employs these microscopic maintenance workers to copy the notes over.
How on earth does a maintenance worker copy a sticker onto a new cell?
Well, when your DNA replicates during cell division, the zipper-like structure splits straight down the middle. So now you have a half-old strand and a newly forming half.
Okay, I'm with you.
The new half obviously doesn't have the do not read stickers yet. But a specific maintenance enzyme like DNMT1 patrols this newly forming DNA. When it sees a metal sticker on the old half of the zipper, it immediately slaps the exact same sticker onto the matching spot on the new half.
So it's literally a tiny biological copy machine for the director's notes.
Exactly. It ensures the epigenetic memory is perfectly preserved, so a dividing liver cell produces another liver cell every single time.
That is just a brilliant piece of biological engineering. So, okay, we understand the machinery now. We know how the cells restrict and allow access to the script. But here is the pivot.
Right.
If the machinery is so good at maintaining the status quo, what causes these instructions to change over a person's lifetime? Because for you, the person listening to this right now, your daily choices are actively editing this script.
We're moving from the tightly controlled environment of embryonic development to the completely chaotic reality of living in the world. Your environment is constantly writing on your genome.
And I think the most striking proof of this comes from studying identical twins.
Oh, twin studies are absolutely the gold standard here. Identical twins come from the exact same fertilized egg. They share the exact same underlying DNA script.
Right.
And when researchers look at them in early childhood, they're practically indistinguishable on an epigenetic level too. Their methyl tags and histone modifications are perfectly in sync.
But as they age, that synchronicity starts to fracture, doesn't it?
It does, massively. As they grow up, maybe one twin moves to a super polluted city while the other stays in the countryside. One eats a highly processed diet, the other doesn't. One has a traumatic medical history, the other remains healthy.
So their lives diverge.
And over decades, their epigenomes begin to wildly diverge right along with them. This phenomenon is known as epigenetic drift.
So by the time these twins are, say, in their 70s, their DNA sequences are still completely identical, but their epigenomes look like they belong to totally different people.
Exactly. You'll see one twin who has accidentally plastered a "do not read" sticker over a gene that protects against tumors, while the other twin still has that protective gene fully active.
This drift concept basically perfectly explains the difference between our chronological age, the number of candles on your birthday cake, and our biological age, which is how battered and worn down our actual cells are.
Spot on. And to understand why this drift happens, we really have to look at the staggering amount of microscopic damage our bodies endure every single day.
Okay, this part of the research genuinely surprised me. I always thought of DNA damage as something that happens when you get an X-ray or sit out in the sun way too long.
I mean, those certainly cause damage, but your own normal cellular metabolism is actually the biggest culprit.
Really? Just normal metabolism.
Yeah. The simple act of converting food into energy inside your cells creates biological exhaust, specifically oxidative stress. And this exhaust physically damages the rungs of your DNA ladder constantly.
Constantly? Like how often?
We're talking about roughly 60,000 microscopic breaks and lesions in a single cell every single day.
Wait, 60,000 times? Just from keeping me alive?
Just from keeping you alive. It forms specific oxidative damage markers like 8-OHDG all over the place.
Okay, so my cells are taking heavy fire just from existing, but obviously my body fixes this, right? Otherwise, I wouldn't have made it to my second birthday.
Yes, your cells have an incredible repair crew. They patrol the DNA, cut out the damaged sections, and patch them back up. But here is the critical flaw in the whole system.
Okay, brace me.
The very act of repairing the physical DNA can accidentally, permanently alter your epigenetic markers.
Why? Does the repair crew mess up the notes while they're fixing the break?
Essentially, yes. When a repair enzyme spots a pothole in the DNA, it binds to it to fix it. But to do its job, it often recruits other specialized enzymes whose whole purpose is to strip away methyl groups.
Oh, no.
Yeah. So in the chaotic process of patching the physical pothole, the repair crew accidentally scrapes off the "do not read" sticker that was sitting right next to it. They call it demethylation.
Wait, so the pothole is fixed, the DNA sequence is completely whole again, but the director's note is just gone.
Poof, gone. And the gene expression is permanently changed. A gene that was supposed to be completely silenced in that cell might suddenly get turned on because its restrictive sticker was collateral damage during a routine repair.
And if you multiply that tiny error by 60,000 repairs a day, over decades,
Yeah.
I mean, you easily see how the simple act of living and aging literally rewrites your biology.
It leaves these permanent epigenetic scars.
But we aren't completely helpless against this wear and tear, right? The research indicates that what we put into our bodies can act as a sort of shield. Like, diet plays a massive role in protecting these tags.
It does. Specific nutrients provide the exact chemical building blocks that your epigenetic machinery needs to function properly.
Like, they found that consuming soy isoflavones or the anthocyanins from bilberry extract, basically compounds found in specific plants and berries, can visibly reduce this oxidative DNA damage.
Exactly. You are feeding your cells the tools they need to neutralize that biological exhaust before it creates a pothole in the first place.
Right. And by reducing the number of potholes, you reduce the number of times the repair crew has to go in, which directly prevents those accidental epigenetic scars.
It's all connected.
Let me push back on this a bit, though. Let's say I don't eat perfectly. I accumulate these epigenetic scars over the years. My stickers get scraped off, my spools get tightened in the wrong places. Is this ultimately what disease is? Are we just talking about wrinkles and aging, or are we talking about the root cause of major illnesses?
Oh, we are talking about the root cause of major illnesses. And
Wow.
this realization has caused a massive paradigm shift in how we view diseases, particularly cancer.
Yeah.
Well, for a long time, the medical community viewed cancer almost strictly as a genetic disease, meaning a physical mutation or a literal break in the core DNA sequence.
But if a cell just loses its epigenetic tags, you don't even need a physical mutation to get a tumor.
Think about how a cell controls its own growth. It has genes designed to hit the brakes and trigger a self-destruct sequence if the cell starts behaving erratically.
Okay.
If the repair crew accidentally slaps a "do not read" sticker over that specific brake pedal gene.
Then the cell never reads the instruction to stop dividing. It just multiplies endlessly. The DNA sequence is perfectly fine, but the epigenetic notes are telling it to become a tumor.
Exactly.
Yeah.
Cancer is now recognized as both a genetic and an epigenetic disease. The malignant growth is heavily driven by these abnormal chemical tags.
But there's a huge silver lining here, right? Because unlike a genetic mutation, where the underlying code is physically broken or just missing, an epigenetic tag is literally just a sticker. It can be removed.
That is the most promising part of this entire field. Epigenetic changes are theoretically completely reversible.
Wow.
You can't easily go in and rewrite a corrupted DNA sequence in a living patient, but you can chemically coax a cell into adding or removing a tag. This has led to an entirely new class of FDA-approved epigenetic medicines.
Things like DNMT inhibitors and HDAC inhibitors,
Yes.
right? So instead of just poisoning the cancer cells with traditional chemotherapy, these drugs are designed to go in and essentially do an epigenetic reset.
They target the specific enzymes that control the tags. If a cancer cell has used "do not read" stickers to turn off its self-destruct mechanisms, these new drugs sweep in, chemically strip away those specific stickers, and suddenly the cancer cell remembers it's supposed to self-destruct.
It restores normal gene expression.
Precisely.
The idea that we can medicate the director's notes is just wild to me. But I want to take a hard left turn here because everything we've talked about so far is very physical toxins, diet, physical cell damage. Let's connect this to the brain and the totally abstract world of the mind. How does the brain use epigenetics to deal with abstract concepts? Like, how do you remember a phone number or a frightening event?
This is perhaps one of the most mind-bending applications of epigenetics. We tend to think of memories as purely electrical, just, sparks flying around a neural network.
Right, synapses firing.
But forming a long-term memory is fundamentally a structural epigenetic process.
Let's break down the mechanics of this because the rat study we looked at sounds like pure science fiction.
Researchers were looking at rats undergoing fear conditioning, basically teaching them to associate a specific environment with a mild foot shock. They wanted to see what was actually happening in the brain cells when a strong traumatic memory is formed.
And what they found completely upends the idea of memory just being an electrical spark.
Completely. They discovered that when the brain creates a powerful new memory, it actually intentionally breaks the DNA inside the neurons of the hippocampus.
Wait, I need to make sure I'm hearing this right. To form a memory, your brain intentionally causes double-strand breaks in its own DNA. The very thing we just said, the cell spends all day trying to prevent and repair.
Yes. Specialized enzymes purposely snap the DNA strands in over 100 different locations.
But why? If I'm trying to remember to avoid a dangerous situation, why is my brain ripping its own script apart? Let's use the script analogy. Is the director literally tearing the pages in half?
It's exactly like tearing the pages out so you can read them faster. Remember how tightly schooled the DNA is around those histones?
Yeah.
When you experience something really intense, the brain needs to immediately access specific early response genes, like EGR1, to physically build new connections and lock in that memory.
Okay.
Unspooling the DNA normally just takes way too long. Breaking the DNA rapidly relieves the physical tension, allowing the chromatin to just spring open instantly.
Oh, wow. So the brain literally breaks the DNA to speed read the script. What happens next?
Once it's sprung open, the cell rapidly strips away the methyl stickers on those specific genes. This sudden access allows the neuron to pump out a massive wave of new instructions in the form of messenger RNAs.
Right.
These instructions are packaged into little molecular cargo ships, neuronal granules, and transported all the way down the dendrites to the synapses.
Where they physically rebuild the connections between the brain cells. So a memory isn't just a spark. It is a physical remodeling of the brain, driven by an intentional epigenetic rewiring.
The psychological experience literally becomes physical biology.
Okay, if my life experiences and my memories are fundamentally altering my epigenome, we have to tackle the massive elephant in the room, transgenerational inheritance. Can I pass these life-altered tags onto my kids?
We are now entering the most fiercely debated territory in modern biology. For over a century, the absolute unbroken rule of genetics was something called the Weismann barrier.
Which basically says that the life choices I make only affect me. If I spend 5 years eating terribly and acquiring all these epigenetic scars, I was taught in high school biology that only my core DNA goes into my sperm or eggs, not my life choices.
Right, the biological firewall. It dictates that traits you acquire during your lifetime cannot be passed to your offspring. Only the pristine DNA sequence gets passed down.
And when that sperm and egg meet, all the epigenetic tags are supposedly wiped completely clean, a total factory reset.
Exactly. The embryo starts with a totally fresh script, but population data has really started to show massive, unexplainable cracks in this barrier.
Let's talk about the Epigenetics study, because this data suggests human trauma might actually echo across generations.
Epigenetics is a remote, highly isolated village in northern Sweden. Because of its extreme isolation and really harsh winters, researchers were able to track meticulous historical records of harvests and extreme food availability during the 19th century.
So they knew exactly when there were feasts and when there were freezing famines.
Yes. They then cross-referenced that feast or famine data with the detailed medical histories of the villagers' descendants decades later.
So they were looking at kids whose parents or grandparents went through severe starvation.
And the results were completely counterintuitive to the Weismann barrier. They found that the paternal grandsons, so the sons of men who were exposed to famine just before they hit puberty, were actually less likely to die of cardiovascular disease.
Wait, so the trauma of starvation in the grandfather somehow conferred a protective health benefit to the grandson. That implies the biological memory of the famine completely bypassed the firewall.
It strongly suggests it, yeah.
Yeah.
And the effect was incredibly specific. If the grandfather lived through periods of massive food surplus, the grandchildren actually had increased diabetes mortality.
And didn't it affect the women differently?
It did. The timing mattered tremendously. For women, the granddaughters of women who experienced famine while they were still in the womb, meaning the famine occurred while their own primitive egg cells were developing, ended up having shorter lifespans on average.
So we have this sweeping epidemiological data in humans. But human lives are incredibly messy. There are a million variables. To really prove this, you'd need to control the environment perfectly. Which brings us to the highly controversial mice study.
Yeah, we have to navigate this carefully as it sits at the absolute center of a fiery scientific debate. It's a prime example of science wrestling at the very frontier.
Right. And to be clear, we are just looking at what the sources say here. We aren't taking a side. So here was the setup. Researchers took male mice and trained them to fear the smell of cherry blossoms.
Right.
They did this by pumping in the cherry blossom odor and simultaneously giving the mice a mild foot shock. Over time, the mice became terrified of the scent alone. Then, those male mice bred and had offspring.
And according to the published paper, those offspring who had never been exposed to the foot shock and had never smelled cherry blossoms before exhibited an innate increased fear response when they were finally exposed to the odor.
They somehow inherited the specific fear.
The authors proposed that the terrifying experience caused an epigenetic change in a very specific gene, the M71 gene, which governs the odor receptor for cherry blossoms in the nose.
And crucially, they claimed this altered epigenetic tag survived the factory reset in the sperm and was passed down to the next generation.
Now, to be strictly impartial here, we have to look at the massive waves of criticism this study received. You can't just claim the firewall is broken without intense scrutiny.
Oh, definitely. Critics totally tore into the statistical analysis. They pointed out that the probability of these specific results being perfectly replicable exactly as reported was impossibly low, something around 0.4%.
They basically said the math was way too clean to be real.
Right. They argued the study lacked statistical power. And a major criticism was that the researchers didn't properly track which offspring mice were siblings.
Which is a huge deal. In biological studies, if you treat a bunch of siblings as statistically independent variables, you ignore genetic clustering. That can severely skew the data and create false positives.
But on the other side of the aisle, the original authors completely stood their ground. They published rebuttals defending their methodology.
They pointed out that the critics had omitted certain negative results in their probability calculations, which made the data look artificially clean in the critique.
Though they did concede they would track sibling mice more rigorously in future studies, so it's basically a stalemate right now.
It is. The mechanical explanation for how a specific learned fear of cherry blossoms could travel from the brain, bypass the Weismann barrier, and selectively alter a single odor gene in a sperm cell remains entirely unexplained. The scientific community simply does not have a definitive answer yet.
So what does this all mean for you, the listener? If we step back from the specific enzymes and the controversial mice, the core message of this deep dive is profoundly empowering.
It really is.
You are not just a static printout of your DNA sequence. You are a dynamic, living document. Your script is constantly being highlighted, annotated, and rewritten by your environment, your meals, your aging process, and even the memories you physically build in your brain.
It's a beautiful, incredibly complex view of human biology. But we have an obligation to ground that beauty in reality. Because the science of epigenetics is still in its infancy, it has unfortunately been heavily co-opted by pseudoscience.
Oh, the quack authors. The internet is just full of them.
It is everywhere. Scientists explicitly warn against the sensationalism spreading in public media. There are authors and influencers making completely unfounded claims that you can magically manipulate your genes, heal any terminal disease, or overwrite your biological reality purely through mind control, meditation, or positive thinking.
Right. The science says that eating a diet rich in certain plants might provide the tools to help prevent an epigenetic scar from oxidative damage. But that absolutely does not mean you can manifest your way out of a severe genetic mutation.
Exactly. Misuse of the scientific terminology creates dangerous, predatory misinformation. Epigenetics is a breathtaking biological mechanism of chemistry and physics. It is not magic.
Which leaves us with a fascinating, provocative thought for you to mull over. We know our choices matter. We know our environment is holding the director's pen and actively shaping our biology.
That much is clear.
But where exactly is the boundary? Where is the line between the empowering scientific truth that our lifestyle impacts our epigenome and the dangerous pseudoscientific illusion that we have complete magical control over our biological destiny?
It might genuinely be the most important philosophical question in modern biology. How much of the script can we actually rewrite before the ink dries?
Next time you look in the mirror, remember, the script may be printed, but the director is always taking notes. And until next time, keep diving deep.